So in this video, we're going to look at how you find a number of significant figures in a number. So here are the rules right here. Simplified it to 4 rules. Rule number 1, non-zero digits are always significant. So 335, these are all non-zero digits. So the number 335 has 3 significant figures. Rule number 2, zeros in between significant figures are significant. So you see 305. Of course, the 3 and the 5 are significant based on rule number 1, but the 0 is also significant based on rule number 2, which says that zeros in between significant figures are significant. Rule number 3, zeros in front of significant figures are not significant. Pretty straightforward. So in 0.003, these zeros are in front, so they're not significant. So only the 3 is significant in that number. Rule number 4, zeros behind, which is to the right of significant figures, are significant only if they are also to the right of the decimal place. So 0.300, they are to the right of the significant figure and of the decimal. So those two zeros right here are both significant. And in 30.0, the 0 at the end is to the right of the number and to the right of a significant figure. So this 0 is significant, and this 0 is in between significant figures, so it's also significant. So basically anytime you have a number like this, 0 to the right of the decimal and to the right of a significant figure, it'll be significant. And in 30, that is to the right or in behind the number, the significant figure 3. But it's not to the right of a decimal, so the 0 is not a significant figure, and the 3 is the only significant figure in this one. So a couple other examples, 0.08550. Okay, so on rule number 1, non-zero digits are significant. The 8, 5, and the 5 are all significant. And here we have the 0 that's to the right of significant figures and to the right of a decimal place. So based on rule number 4, that 0 is significant. So we have 4 significant figures in this one. And now let's look at this one, 0.0045. So these zeros are all in front of the significant figures. So rule number 3, ones in the front are not significant. They don't matter. Only the 4 and the 5 do. So this one has 2 significant figures. Lastly, 33.0. Well, here's a little shortcut. Anytime a number is written in scientific notation, all the figures are significant every time. So 3 numbers. So that's a quick summary of how you find significant figures. Now we're going to take a look at scientific notation. So in scientific notation, we want to simplify big numbers or small numbers, make them all standardized in a format where we get a number from 1 to 9. And then that number is multiplied by a power of 10. So we have the basic rules spelled out here. Here, move a decimal, right or left. The outcome is an exponent that becomes negative or positive. Basically, you're subtracting a negative amount or adding a positive amount. Here's a quick example. What's 1,000 grams in scientific notation? Well, let's look at the decimal. It should be right here. Move it over 1, 2, 3 to the right. Now it's 1 times 10. We know it's 10 to the third because we moved it to the left. The left means positive. 10 to the positive third power. So now let's look at another couple more. Let's look at 7,112. decimals right here. 1, 2, 3, same as before. 7.112 times 10 to the third power millimeters. 0.05 millimeters. This time we're going to move it 1, 2, 5 meters. 5 times 10. In this case, we move it to the right. So it's a negative exponent. 5 times 10 to the negative second power. Finally, 505 liters. So we're going to move it over 1, 2 to the left. 5.055 times 10. Since we went left, it's positive. Positive 2. Second exponent. Liter. And it's that simple. It's pretty straightforward.